Okay, we have one example on this page, and we'll do it right now. We're going to use a u substitution on this one. Can you see something that you can let u equal that will be a derivative of something else in this equation? Take a good hard look. And the answer, is x cubed. That's a tricky one because there were three different things we could have let u equal, but the best one in this case is x cubed, which means that du equals 3x squared dx. Okay, let's go ahead and solve for dx. Dx equals 3x squared over d. Whoops, I got that backwards. That would make a mistake. Dx is equal to du over 3x squared. That looks a little bit better. So we're ready for our integral. And notice that this time it's going to be a definite integral. So that's going to be 12x squared e to the u, because that was our substitution. And then we replace dx with du over 3x squared. Just like that. 3x squared cancels with 12x squared, just leaving a 4. So that means that we've got the integral from 0 to 5 of 4 e to the u du. All right? Hopefully all of that makes sense. I went through that kind of quickly. Feel free to rewatch it if you need to. So let's go ahead and take the integral of that. And the cool part is the integral is just the integral. So we just get 4 e to the u, evaluated from 0 to 5. Okay. Now, there are two ways that we can do this because we need to be really, really careful right here. All right? One thing we've kind of left out up until this point is that when you're doing an integral with bounds, these two bounds are whatever variable this is right here. So these are x bounds because we have a dx. All right? So before, I'm going to show you two ways to do this, a longer way and a shorter way. All right? The longer way is we need to go ahead, and these are x bounds, right? So we need to go ahead and put this back in terms of x before we evaluate. I maybe shouldn't have even have written this with the 5 and 0 u because these are x bounds and you could not plug them in right there. So before we evaluate this, we need to turn it back into x. So this would be 4e to the x cubed 0 to 5. So this would have been wrong. This is correct because these are x bounds. All right? So that means the final answer is 4e to the 5 cubed, right? 4e to the 5 cubed minus 4e to the 0 cubed, all right? Which will equal 4e, 5 times 5 times 5 is 125. 0 cubed is 0, e to the 0 is 1, so it'll be 4e to the 125 minus just 4. Okay, that's kind of the long way to do it. It wasn't so bad because we only had one term, but sometimes you have lots of terms. Let me show you a kind of smarter way to do this. This is perfectly valid. This is the answer right here. Okay, what's a smarter way to do it? You'll remember I said that these are x bounds, but don't forget that we have a link between x and u. And so what you can do is go ahead and put your x bounds in here, and you can turn them into u bounds. And on some integrals, this saves a ton of time. So what we have now is 4e to the u, and we'll plug in our 0 bound. 0 times 0 times 0 is 0, so the lower bound stays the same. Then we have our 5 bound. 5 times 5 times 5 is 125. And so now these are u bounds instead of x bounds. And now we can just evaluate this this result right here from 0 to 125. And notice that when we do that, we get 4e to the 125 minus 4e to the 0, which is 4e to the 125 minus 4. And so notice we get the same answer because that e to the 0 becomes 1. On this problem, that process did not save very much time, but as I said, if you have an integral with 4 or 5 things, it can be much easier to transform your x bounds into u bounds than to go ahead and substitute the x back into the overall thing. Anyway, hopefully that makes sense. Now you know how to do u substitution with bounds. That actually is the end of this section. We have one more to go in this chapter, and I will see you in the next video.